Okay, we're going to start out feature geometry in this video, and I think I'll probably go through the general architecture of feature geometry theory and how it applies to uh, major place features in particular. Then I'll save the rest of the features for another one or two videos. Um, so let's start by going back to our original sort of matrix-based sound patterns of English kind of a theory that we started the semester with. And this should be very familiar now because we've come back to this two or three times and seen all the ways in which this segment matrix-based theory breaks down and doesn't account for some kinds of phonological generalizations. But here's what the theory looks like. Remember that segments are feature matrices. They are discrete, they're temporally ordered, and each slot is exhaustively specified for all features. So the representation for the sequence T, for instance, would be all of the many, many features associated with the segment T grouped together in a single discrete matrix, followed by a second discrete matrix with all of the features exhaustively specified for the segment E. And we've written the IPA symbols as abbreviations up here at the top of these matrices, but of course they're not formally in the theory at all. There's just these exhaustively specified matrices of distinctive features. Phonological rules in this theory will change some feature values in the context of some other feature values, with all features and all values, whether it's voicing or continuancy or labial or plus or minus, all created equal. So there's no theory of which features are related. These are simply formal transformations over formal objects. So here are two problematic aspects of this system. One of them we spent the last several months sort of fixing, right? And that is that there's no way to express horizontal feature continuity dependencies. That's what I named them when we looked at spreading and harmony processes in autosegmental theory. Those are horizontal generalizations in the sense that features tend to change to be like things in their context. So there's a link between feature values in one location and feature values at other horizontal locations with regard to our writing system. And that was the motivation behind autosegmental metrical theory in the first place. This unit is going to be about a different problem, and this is that there's no way to express vertical feature co-occurrence dependencies. What does that mean? Well, some features tend to occur together in phonological generalizations, while others don't. That's basically what we're talking about here. Let me show you what I mean by feature co-occurrence or vertical dependencies. So again, going back to our sort of abstract Greek variables and letters kind of a notation, we can think of all rules as taking some value of some feature, maybe more than one feature here, and using them to fill in this rule schema, this framework, where we have a structural description done in feature values, and then a change that happens to the natural class of things in that structural description. This is the change that affects them, again, in values and features. And this happens in some context. Here I've just done a following context, not a preceding one, but of course there could be either or both. And these are all going to be stated in terms of feature values, right? So typical rule here, we're saying, hey, for all the natural class of segments that have alpha f and gamma h as features, change them to make them beta g and delta I in a context where the next thing is also beta g and delta I. So this is going to be a classic assimilation rule. Right? And we've already observed that, hey, these things here tend to be the same as these things here. That's what assimilation is. And we tried to address that through autosegmental theory. Here's a new problem. Looking vertically, right, at the top feature and the bottom feature, top feature and the bottom feature here, the claim is that certain combinations of G and I in particular are very, very common in the world's languages. If you look at all the rules that you can find across the languages of the world, you're going to find some combinations of feature G and feature I that are really common, while other combinations of two features are really, really uncommon or even unattested. Right? Another way of putting this is that feature theory itself seems to include some dependency structure, meaning that if we know one phonological feature that's being changed by a rule, then we actually already have some information about what other features are likely or unlikely to also be changed by that rule. This is the problem that we're trying to address here with feature geometry. So again, we're seeing a situation here where the feature matrix theory can describe existing phonological processes. That's not the problem. The problem is that they also allow for tons of unattested rule types. So overgeneration problems, again, predicting all sorts of crazy phonological rules that don't exist. Why is that with regard to this particular problem? Because phonological operations tend to target some sets of features, but not others. And this is very much parallel or similar to the concept of constituent structure in syntax. I'll go into that in a minute, but just keep that thought in your head. So here's a concrete example of a bunch of features that clearly form a featural constituent. And we've already seen this several times in this class. The major place features, right? So our features are labial, coronal, and dorsal. In the original sound pattern of English theory, the three features were coronal, anterior, and back, but they're doing pretty much the same thing, although the details are a little bit different. These are the major place features. A lot of the examples in this handout are from John McCarthy's 1988 paper, and he's going to be using these SPE place features, but you can just sort of mentally substitute wherever you want to our features, coronal, labial, and dorsal. They don't work exactly the same, but they're very similar. So how do we know major place features form a featural constituent? Well, we've seen this over and over again, trying to write assimilation rules or debuccalization rules in this class and even in the previous semester. These features essentially always occur together in these kinds of assimilation or delinking rules, yet that's very, very hard to describe in the segment-based theory without having to use some fancy Greek variable notation. So there's a couple senses in which these major place features have some unity to them. So for one thing, phonetically, just physically, these are describing the location of a constriction, of a physical event in your vocal tract. So they're sort of coherent or sensible as a grouping in that respect, physically, phonetically. And then the maybe more important one here for phonological theory is that they frequently occur together in the statement of phonological rules, right? And we've seen various examples of that. Let's take a look. So this is again from the McCarthy paper. So he's going to be using coronal, anterior, and back for major place features. They're slightly different than our major place features, but the overarching point here is exactly the same. Widely attested rule shown in 1A here, right? Nasal place assimilation. So a nasal segment takes on the values for all the major place features of whatever segment comes after it. Right? And this is McCarthy indicating that these Greek letters, alpha, beta, gamma, are variables over plus and minus. Right? So if this is plus back, then this is plus back. This is minus back, then this is minus back, and so on and so forth. What does this do? Well, it takes input sequences like this, in, complete, and it changes them into assimilated clusters here. So incomplete. This nasal becomes velar before a velar stop. Very, very common cross-linguistically. Here's a kind of thing that could happen in this theory, but doesn't. 1B here. This takes the features coronal, nasal, and sonorant and assimilates them in a nasal to a following segment or stop in this case. This would be just like major place assimilation, except instead of grouping together coronal, labial, and dorsal, this is going to group together coronal, nasal, and sonorant, right? And it's going to take on the values of a following segment for all of those features. And so in English, for instance, this would take an input segment sequence like incomplete and turn it into, I think this is going to be a voiced pharyngeal fricative or something like that. I don't even know how to pronounce this. It's going to be something like incomplete. Right? This is not something that happens in English. It's not something that happens in any other language that we're aware of. This is a totally crazy phonological rule right here. Here are some reasons of thinking about why. So before we even come up with a theory of featural geometry, why aren't coronal, nasal, and sonorant a useful featural constituent? Well, phonetically, again, physically, with regard to what your vocal tract is doing, this is an eclectic set of phonetic properties that have nothing in common, right? So one of them involves where the constriction is in your vocal tract. One of them involves whether or not your velum is raised or lowered to couple your oral and nasal cavities. And one of them involves how tight the constriction is in your vocal tract, or how intense the sound is. And none of these three properties have anything to do with one another. They're all completely independent from one another. And so they don't make sense as a physical group or unified property. And then phonologically, no rule seems to make reference to this set. So that's why these are not a featural constituent. So that said, the job of feature geometry as a theory is going to be to capture dependency and constituency for the features that are constituents, while also not doing so for the sets of features that are not constituents. So the central observation here, some sets of features form constituents to the exclusion of other features. We get those constituents by examining phonological rules and seeing what kinds of sets of features co-occur to the exclusion of other features, right? So place of articulation features often pattern together in rules to the exclusion of other features. Examples, nasal place assimilation, which we've seen over and over and over again in this class, seems to involve all the place features at once, but doesn't necessarily involve any other features, although in some cases it can. It can also just be place features by themselves. Similarly, debuccalization, which we've now seen several times last semester and this semester, seems to involve delinking all of the place features at once. Compare this to coronal, nasal, and sonorant, on the other hand. We haven't seen any rules in here where coronal, nasal, and sonorant pattern together to the exclusion of other features, right? And the example that we just looked at of what a rule like that might look like doesn't look like anything that we've seen in class, and it doesn't look like anything that I've seen in my considerable experience with studying phonological patterns. So that's pretty clearly not a constituent. Right? Why do I keep saying constituent here? Well, I'm borrowing that term from syntax. And what does it mean in syntax? Well, constituents refer to situations where some elements pattern together in grammar and other elements don't. Right? So in syntax, we represent the difference between constituents and non-constituents using hierarchical structure. So we say that there are units, like phrasal units, that contain some elements but not others, and that any set of elements that's exclusively contained in a phrase or a unit is a constituent. So for instance, if verbs and objects pattern together in some kind of grammatical phenomenon, maybe it's ellipsis or maybe it's WH question formation, and if verbs and subjects don't pattern together in those phenomena to the exclusion of objects, then we say that this is because there's some larger unit that contains the verb and the object but doesn't contain the subject. There is no larger unit that contains the subject and the verb but doesn't contain the object. Therefore, subject and verb can't pattern as a constituent to the exclusion of object, but verb and object can pattern as a constituent to the exclusion of the subject. That unit, by convention and syntax, is referred to as a verb phrase. Right? But this is the basic form of the argument. We look at some phenomena. So if you can say, the little mouse ate some cheese on Friday and the cat did so on Wednesday, then that's an ellipsis phenomenon where the verb and the object are patterning together. You can't do the same thing with the subject and the verb. It doesn't work. And therefore, we better have a theory where you can have a structural unit, a constituent, that contains the verb and the object, but not the subject. We call that a verb phrase. This kind of logic seems to have worked out pretty well for syntax. And so in the 1980s, phonologists decided to borrow the exact same idea here for feature structure. Now, for whatever reason, instead of calling this feature constituency, which would have been a much clearer label, they decided to call this feature geometry, which makes it sound really, really complicated. It's not that complicated. It's basically just doing syntax with phonological features, trying to figure out which features are constituents. So a feature geometric analysis of nasal place assimilation might look like this. We would say that all these major place features, coronal, labial, and dorsal, and presumably also radical for languages that have radical consonants like pharyngeals or things like that, we would say that these are dominated by a place node. And in fact, this is already implicit in ways I've been writing these in class. Sometimes I'll just say that they need to assimilate place to the following place. This is what I'm actually referring to, this theory where all of these features, coronal, labial, dorsal, they're contained in or dominated by the place node. Now, a node is just a name for a point in a tree structure, basically. So the spreading rule in 2a here is going to target not coronal or labial or dorsal, but is going to target the place node. The place features, coronal, labial, and dorsal, are going to be whatever they are down here. They're all going to be contained in this place node, and it's the place node itself that's spreading from a consonant to a preceding nasal. This is a spreading of place to a preceding nasal, and it's going to take whatever's underneath here along with it. Right? This is how place assimilation is going to work. And so the claim here is that it will take inputs like 2b and turn them into the outputs in 2c here. So here are the input representations. This one is a labial, so it's minus coronal. In terms of the SPE features, it's plus anterior and minus back. In our system, that would be a little bit different using our features, but the basic idea here is the same. There's going to be 3 major place features. They're going to be different for p, t, and k. And each segment here is going to have a place node that dominates or contains all of these major place features. And then once you spread that entire place node to the preceding nasal, you're going to get complete major place assimilation. Mp, nt, and nk. So it takes these inputs and turns them into these outputs by spreading the entire place node along with everything underneath it. Now, that unattested rule, the crazy one with coronal, nasal, and sonorant patterning together, in this theory is unlikely to ever occur. Why? Because coronal is under the place node, this constituent we just looked at. Nasal and sonorant are in totally different locations in the feature tree. We'll look at that later. So all 3 of these, if you wanted to get just coronal, nasal, and sonorant spreading, all 3 of them would have to spread independently. There'd have to be 3 separate rules that just so happen to spread each one of these features in exactly the same places in some language. And that is very, very unlikely. It's much less likely to occur than a single spreading rule, which is all that you need to get place assimilation. Because they're not in the same constituent, they're never going to spread together. That's what coronal, nasal, and sonorant are like in this theory. So here's the unattested rule. This is a nasal that takes on the coronal, nasal, and sonorant features of whatever segment follows, and it does this crazy thing. You'd have to have one rule that spreads coronal, right, and that lives over here. A second rule that spreads nasal, and that lives somewhere completely different. I've just given it an arbitrary label here. And then sonorant lives somewhere different yet again. I've given that an arbitrary label too. You'd have to have 3 different rules targeting these 3 different nodes in feature geometry, as opposed to place spreading, where all you need to target is one node. So taken together, this is evidence from spreading that place features, major place features, pattern as a single unit to the exclusion of other features in a way that, say, coronal, nasal, and sonorant do not. In other words, this is evidence for the place node or the place constituent, and that evidence comes from spreading. Now, McCarthy mentions 2 other sources of evidence. Oh, and I've written here for autosegments. That is a typo. These are other sources of evidence for featural constituents, that is, for feature geometry nodes, not for autosegments. Sorry, this was wrong. So other sources of evidence for nodes is going to be delinking. So we've seen spreading. The other major things here are delinking and OCP effects. Right? So for OCP place, major place features, we looked at this in detail in Arabic a few weeks ago. So we saw that there are restrictions there on verb roots where you couldn't have the same place of articulation for the first and second or the second and third consonants in 3-consonant verb roots in Arabic. So this is precisely what we'd be looking for, an OCP pattern that targets not just coronal, not just labial, and not just dorsal, but all of them, all major place features. So we already have evidence for, again, the place node in feature geometry. We also have evidence from OCP effects in Arabic. What about delinking? Well, this should look familiar by now. Again, debuccalization patterns that we've looked at work the same way, changing, what needs to be changed. It's delinking rather than spreading. But the point here is just that you have a segment. It's maybe at the end of a syllable or at the end of a word. And what delinks? Not individual coronal, labial, or dorsal features, but the node that contains all of them, the place node or the place tier. This delinks from a segment and it leaves it without all of its major place features. Other other features are left intact. If it starts out voiceless, it stays voiceless. Starts out a consonant, it stays a consonant, so on and so forth. But these 3 features pattern together to the exclusion of some other features, so we write them as a constituent here. We've seen debuccalization in a couple of varieties of Spanish. It's also discussed in the Husenhoven and Jacobs chapter, which is on the website. We saw it in the homework in our Bore, in one of our homework assignments. And here's another case of debuccalization from a completely different language family, from Athabascan, which is indigenous languages of the northwestern United States and most of Canada. So this is from the Northwest Territory of Canada. It's a language called Slavey. And here's some examples of how debuccalization works in Slavey. What you have here is the same stems in prevocalic position and word final position over here. So the prevocalic position, these all have a suffix that seems to be a possessive, and that suffix takes on the form a. So before that suffix, before the vowel, you can see that each of these stems, rope, hat, and river, all end in 3 different consonants here. This is going to be a voiceless lateral fricative. So this is going to be something like tilde. This is going to be a voiced coronal stop, t'ade. And this is going to be a glottal fricative, so deje. You take away that vowel by taking away the possessive morpheme and put these in word final position and just have plain stems here. All of them are realized as the glottal fricative ha. So again, before a vowel, you can see that there's 3 underlyingly different consonants here. These would all need to be in the URs because they're contrastive. Right? But word finally, these all neutralize to a glottal fricative with no place features. So we saw in our Bore this happened before consonants, but not at the end of a word. In Slavey, it looks like we get it at the end of a word and before consonants. So we have these compound words that are 2 stems together. You can take the same stems from up here. So this first one is rope, and this one over here is hat. And you add a second root to them to make a compound word. You get, again, debuccalization in the output here. So what we're seeing here is that all the major place features here of these segments, whether they start out with major place features or not. So by hypothesis, the glottal fricative here doesn't even have any place features. This one is underlyingly unspecified, and it stays the same at the end of a word. This one is underlyingly specified for coronal and for minus labial and minus dorsal. Those all delink at the end of a word. And this one is specified for coronal and lateral and presumably non-labial, non-velar as well. And those all delink at the end of a word. And all 3 of these come out the same, as well as before a consonant. So that's debuccalization in Slavey. It's not just one place feature delinking. Just like all the other examples we've seen of debuccalization, it's all of the major place features delinking, just like this diagram suggests. Right? So here this is shown at the edge of a syllable, in coda position of a syllable, and that seems to fit Slavey pretty well because it's happening at the end of a word, which is necessarily also the end of a syllable, but also before obstruent consonants, and that makes sense if you think that obstruent consonants need to be in the next syllable over here. Then it follows that those consonants that are debuccalizing are at the end of the preceding syllable. So that's evidence from spreading, from delinking, and from the OCP that all of the major place features pattern together as a featural constituent to the exclusion of other features. In other words, the place node is very well motivated by phonological patterns. The rest of this unit is going to be about what about other features? What about other kinds of nodes? What is out there? What exists? And how do we find evidence for them? That will be the next video. Thank you.